Let's solve some non-right triangles using the law of cosines. So non-right triangles, we're going to say this is part 3 of this discussion. So non-right triangles, well, they are triangles that don't have right angles in them. So we are going to use the law of cosines. And if you will recall from part 1, if you watched part 1, the law of cosines works really well if you've got all 3 sides, which in geometry they call that side, side, side. So that's, all 3 sides. Or side, angle, side. You know a side, the angle next to it, and the side next to that. So side, angle, side is what that's called. And if you've seen that in geometry, that's what we're using, although we're not actually doing any geometry proofs or anything. So let's say I've got an example. And my example has this. It has A is 28, B is 47, and C is 58. Now, I could say that those are inches, just to give them some kind of measurement. So I'm going to go inches, inches, and inches. So the task is to solve the triangle. There are some actual practical reasons for this, not just solving triangles, but this is how we start. Now, the law of cosines. The law of cosines is much like the Pythagorean theorem. One version. So one version is a squared equals b squared plus c squared minus 2ab cosine of a. A and A. This is like the Pythagorean theorem. This is kind of like a middle of AB. Whoops. BC. Excuse me here. I messed up. This is kind of like a perfect square trinomial also. So you use this one and this one right here. So that's one version of it. Now I'm going to start with A just because I want to. So I've got A squared. So if I write A squared, let me write the version of my law of cosines correctly here. A squared is B squared plus C squared minus 2BC, and then the cosine of A. So if I put the numbers that I've got in my problem in here, I've got 28 squared is equal to B squared is 47 squared plus C squared, 58 squared, minus 2 times 47 times 58 times the cosine of A. The only thing I don't know is the cosine of A. Let me move everything over, and then we'll get the calculator out. So if I move this over, I've got 28 squared minus 47 squared minus 58 squared, put that in parentheses, you don't need to, is equal to minus 2 times 47 times 58. So let me go ahead and put 2 times 47 together. That would be 94. So this is equal to minus 94 times 58 times the cosine of A. So I need to divide by minus 94 times 58, and then I'll have cosine of A by itself. That's using algebra. So now this stuff is gone, and I'll pull out the calculator and we'll see what we can do here. So if I've got the calculator, I've got 28 squared minus 47 squared minus 58 squared. Now I did not put parentheses, so I need to get a total. So this is minus 4789 divided by, now let me take this and divide by, I've got to get parentheses, so I take all of this together. I've got minus 94 times 58. So 94 and 58. So minus 94 times 58 is approximately 0.8783932.502. Okay, it goes on and on. Now, can the cosine be equal to 0.87? Yes, it can. Cosine values are all possible numbers between -1 and +1, and that's between there. So I can find the inverse cosine. Now, there is no chance of having two triangles in the law of cosines, because if you have a negative for this answer, then it's going to be a quadrant 2 angle, and if it's a positive, it's a quadrant 1. In law of sines, both sides, quadrant 1 and quadrant 2, were both positive, so that one had a little bit of a different scenario. So let me take this, and let's find the inverse cosine. So inverse cosine, and then I'm going to come up and grab this number. So I hit enter on that, close the parentheses, although that's not required, and you get this. You get A is approximately 28.55 degrees. All right, I'm in degrees, so that's what I've got. So there's one angle that I did not have before. Now let me find the other two. So let me set this up. This was for A, so let's do B. So B squared is equal to A squared plus C squared minus 2AC cosine of B. So if I remove the things over, and you'll see a pattern here, so I'm going to take B squared, which is 47 squared, is equal to A squared, 28 squared, plus C squared, 58 squared, minus 2 times 28 times 58 times the cosine of B. So I'm going to subtract these over. I've got 47 squared minus 28 squared minus 58 squared. And then I'm going to divide by this. So minus 2 times 28 times 58, I'm just skipping some algebra steps, is equal to the cosine of B. So let me pop the calculator into the screen so you can see that. So I've got to take 47 squared minus 28 squared minus 58 squared. Now I've got to get the number because I didn't put parentheses. So minus 1939 over minus 2 times 28 times 58. So divide by, I've got to put these in parentheses. So minus 2 times 28 times 58, close parentheses. So I've got 0.59, so 0.5969827586. So if I find B, I've got to find the inverse cosine, and I push that, and then I come up and grab this number, and it would help if you could see that, inverse cosine of that number, and then I hit enter, so I've got this angle, which is supposed to be B. So B is approximately 53.35, so 35 degrees. Now you don't have to do the third one because triangles add up to 180. So if I take 180 and subtract the angle measurement for this one, so I'm just going to grab it, and then I'm going to subtract the angle measurement for the last one, which I've still got on the calculator. It's all the way up here. Then I get the third one. So I had a value for A, I had a value for B, now my value for C is approximately 98.5 0.10. So there are the three angles. We started with 3 sides. We found the 3 angles. Let's try another example. So my next example is going to be one with side angle side. So let's check that out. If I've got something with side angle side, let me draw the triangle for you. So let's say I've got this, and then I've got this, and then I've got this. So it's not a right triangle. And let's say that this one, this side right here is 8. This is an angle of 20 degrees. And then this side right here, that looks like it's maybe, maybe 14, okay? And so I don't know the rest. Well, I've got to label these and see what I come up with. So let's not solve the entire triangle on this one. Let's just say that this is angle C. C is 20. And let's find side C. So what is side C based on these 2 pieces of information? I could solve the entire triangle, but we don't have to do that every single time. So let's set this up. Well, what's C? One of the versions of the law of cosines is this. C squared is equal to, see that solve for C, so if I get that, I won't have to do any extra algebra, but it's equal to A squared plus B squared minus 2AB cosine of C. Now, which one's A and which one's B? It doesn't matter on this because I'm not distinguishing. So let me just label them. This is A and this is B. So we've got C squared is equal to A squared, so that's 8 squared, plus B squared, 14 squared, minus 2 times 8 times 14 times the cosine of C. So, and what is C? C is 20 degrees, so I can actually put a number in there. So now it's all set up to calculate. So we've got C squared is equal to 64 plus 196 minus, and then 16 times 14. I should know that, but let me get the calculator going here, okay? So 16 times 14, so that's 224. So 224 cosine of 20. So I'm going to pop those in the calculator. So I've got 8 squared. Let me just make sure that I've got all my right numbers. So 8 squared plus 14 squared, and then minus 224 cosine of 20. Cosine of 20. Now I'm in degrees, so I'm sufficiently fixed up for that. I've got C squared is about 49.50885294. Okay, I need to find C, so I need to take the square root. So let's take the square root, come up here and grab this, and then just hit enter. So C is about 7.036252763. Since I used integer answers, I'm going to say C is about 7. So that answers my question.